speaking for both me and Savita from TCS, I don't think we will be talking much about geospatial today. Obviously, let me also let me give you before I start off, and this is not a part of the formal presentation. I've been in the government. I've been doing government projects for a long while now. That's how I and Dr. Mukund met. And GIS in the government is at a very interesting inflection point. The first project I think we got together was in December of 2009 for BESCOM. We will talk a little bit about it. But we sort of sweated our way through the project because the technologies at that point in time were the technologies of that point in time. We really can't help it. Now, today I was privileged to sit through a few lectures. I find that there is a lot of progress that has been made in the geospatial arena. What is also interesting is if you look at the entire science of artificial intelligence, which is what I teach, artificial intelligence is of course a catch-all phrase, and the subsets of artificial intelligence are machine learning, computer vision, so on and so forth. So I would say machine learning, which is more mathematical and more understandable. There is a lot of software today which can do a lot of image analysis, which can correlate voice, image, and other data to give you a lot of information. And there are a lot of mathematical methods, like I was talking to Dr. Mukund, like Bayesian logic, which can really help satellite images. I think what are the purpose and opportunities of big data? I'll focus mainly on the government. I'm happy to talk to you about the private sector. Private sector is doing a lot of work. Infosys does a lot of work. I'm sure Madam here will also talk about what TCS does. But then I'll focus on the government. I'll talk about what has been our experience, and I will talk about what is the evolution and beyond. If you look at the online transactions, what has happened if you look at it at a very different space? Nothing political about it, but in the last 5-6 years, I'll include the 6th year for the sake of political correctness, there has been a lot of online data. So today, if you take any regulatory filing, any income tax, for example, the number of income tax filings itself was 6.68 crore income tax e-filings. All this is data which I deal with on a day-to-day basis. The number of companies registered in the country as on 31st December stood at 20 lakhs. And we process 60% of Indian banks use Finacle, which is our core banking system. So about 2.8 million transactions are being processed digitally. Our system, the BESCOM system, uses 80 lakh BESCOM customers are on a GIS and an IT platform. And a total of 1.22 crores businesses are registered with the GST. Yeah, I guess now I got a hang of it. Now, when we talk about GIS, GIS is actually a part of a bigger platform. And when I say a platform, what are the sort of attributes I look for? You should be able to collect and fuse data. Today with API crawling, you can almost have on-demand data at any point in time, and you can sort of get data which you can annotate, we can do at any point in time. Analyze data in multiple dimensions using descriptive analysis, machine learning, deep learning, causal networks, network analysis, text and image analytics. This is where I would say a lot of effort has gone in, and all the spatial image, etc. that we talked about has to fit into this. Now, obviously one has got to monetize the platform, but then I think Colonel is here and he'll tell you the platform security is one of the biggest things. How do you ensure that the platform is used for what it is meant to be used for? The To do that, we possibly need to have, how do you store and pre-process data information? How do you disseminate the information through self-learning reports, APIs, visualization techniques? And how do you sort of scale on-demand IT infrastructure platforms? So I would think that there is an interesting thing going on, which I shared with Dr. Mukundra also. We are trying to build an operating system called Bharat Maps, because I believe the next operating system, apart from iOS and Android, iOS and Android ran on processors, in the sense that they ran on data. They didn't run on the spatial network. But with today's computing and quantum computing not being that far, Google has actually said that they have used, they call it the Sycamore. I would think that the next operating system will be a spatial operating system. The big data is the game changer in making e-governance possible. Now, for example, Geo Tagging. Now, we all heard of demonetization, and we all heard a lot of newspaper articles where 6 lakh companies were deregistered. A part of that was Geo Tagging, because one of the few things that one of the jocular elements, just to make it lighter after a heavy lunch, was there were 50, I don't think it was 50,000, it was at least 15,000 companies registered in one address in Calcutta. So, so you can see, the amount of fraud that you can do. Obviously, when you start geotagging, you can say room number 212, you can put some other name and all that, but when it finally goes to geotagging, you can finally find all of them are from the same building in Calcutta. Okay, and I don't know how many of you have been following the economic newspapers. There is DHFL is going belly up. In the MCA, there is what is called an asset register, where you can create an asset. I would say when you hawk your asset, you can go and register it in the MCA. Okay, so that if somebody else is going to buy the factory, he knows that it is already pledged to somebody else. But when we did geotagging, we found that the same assets were hawked twice, thrice, etc., etc. Okay. Now, the agriculture. Niti Aayog had developed a model for crop yield production. I think Dr. Mukundra was also saying that you are also doing some work on that. Obviously, a lot of information is getting processed. I'm not an expert in that, but then I'll come and talk about it a little later. We'll talk about the poverty programs a little later. Some of the programs which I can talk to you about is Project Insight. Project Insight is a project by the Income Tax Department. It does a geotagging. It does a geotagging of you. It does a geotagging of what houses you say you own. It also scrapes from the net all the photographs that you would put up on Facebook. It creates a consolidated profile of yours, and it says, okay, Mr. So and so, your income should be 30 lakhs or 40 lakhs. You please, if you declare lesser than that, please come in and explain why. Because the way you have geotagged your properties, that property should be worth a few crores. Now, goods flow. To see the flow of goods in India, the transaction level data is available on GSTN. You can see where goods flow from one place to another, and this gives you a good economic data. The Kerala Water Authority is using analytics and mobility to analyze and manage water distribution in its capital. Now, Transport AP government is using big data and analytics to launch a real-time monitoring system. And I'll talk a little bit in the next few slides about the policy, and I'll talk about poverty. Now, I just touch upon it here, but a lot of the sensitive arms of the government use big data, machine learning, etc. to keep our borders safe. They include things like, you can have social media platforms where you can see what people who are no gooders or do badders get a lot of data. You can get data from the government, the defense, the partners, the central government, etc. And you can use all this data to create your own sort of a platform to look at incidents. I can give you an incident which possibly happened many years back, so it is off the classified list. So we had an incident where there was a chap who it was a curfew lockdown in Kashmir, and this guy draws 50,000 rupees from an ATM in Kashmir. And obviously during a curfew, why the hell do you want 50,000 rupees? You can't go party anywhere, you can't do anything, so what are you wanting it for? So using geo tagging, we found out where the ATM was. Using the cameras there, etc., and the cameras nearby, we figured out who this guy was. Using his card, we found that was a card registered in the UK. Then we identified this person. He had come in from one of the West Asian countries. He had come in just 2 days back. He had gone into the West Asian country from our neighbor in the West, and he had come in from that country to Bombay to Chandigarh. He had come to Amritsar, and Amritsar he had taken the bus. So we traced him all the way back, and then obviously the rest, of course, I don't know, but I guess the security agencies would have taken care of it. Okay. Now on the social front, we did a very interesting exercise in Andhra. There is what is called in Andhra, where I grew up there. So when I say something a little flippant about the state, I'm Andre Andhra. So the Andhra government said that, I think it was during YSR's time, they said that you can declare yourself to be below poverty line, you will be given a ration card. 85% of Andhra guys said I am below poverty line. So now how do you identify a lot of the social programs? So what we did was we went into 18 different databases of the government of Andhra Pradesh. We picked up a lot of data from the government of Andhra Pradesh. We created a mathematical algorithm to say who is really the poorest of the poor. So we said, again, we used a very preliminary, it was a few years back, so GIS was not that prevalent, but we did use how many acres of land he had, whether the land was actually cultivated, how many buffaloes he had, how many days of mandriga stuff that he had got, and then we created a roadmap for what in Sanskrit or in most Indian languages would be called Daridra. We said who is the actual Daridra, we called it POP in a very euphemism, poorest of poor. And then we said let's focus on bringing these guys out of abject poverty to poverty. We are not saying we are going to make them rich. So we used a lot of big data, we used a lot of analytics to solve such problems. This is what we are also talking about here. Now if you look at some of the government dashboards and the government data, it is pretty, the direct benefit transfer is one of the key attributes that has evolved over the last 5-6 years. So two things have happened. One is imaging has helped the Mandriga program as it is run right now to actually say what is it that you are building for the government and what is it that you can sort of then build out, how are you charging them, because otherwise there were a lot of frauds on that. And then how do you use the data to actually do a genuine business transfer by creating bank accounts, by creating Jandan accounts, by creating all these accounts so that there is a direct business transfer. Of importance is also the fact that supposing can you use it for epidemics. Now I'm sure all of you have a mathematical background here. How many of you are familiar with Bayesian logic? Okay. Bayes is the Bayesian logic. Bayes was one of the ministers, religious ministers, not the political minister in the UK, and he wrote a very good thesis, how you can change the probability with improving time. So in the field of medicine, when it's in the field of epidemics, like the one that is going on right now in China, whether the epidemic is spreading or not, you get it by using something like a Bayesian logic where the probability of the epidemic spreading changes every hour, or the probability goes down if you are using control measures. So can you use a lot of big data to solve that problem? Now there is a lot of, I can come back to this, and there are a lot of government platforms. The Indian economy, you can get it all from RBI, the Indian Earth Observation, National Portal of India, the Survey of India, India Weather Data, the other metadata, Wildlife Institute of data sets. So all these are available here. Private data you can get arguably from all of this, either you scrape it, of course you can get all of this. So you can make a picture of what is going on, okay, and this will help you both in national planning as well as in implementation of programs, okay. For example, one of the key observations in the last economic survey with the chief economic advisor had was India is growing, India is actually shrinking. The total fertility rate, I am sure all of us know what a total fertility rate in Kerala is 1.2. The total fertility rate in Tamil Nadu is 1.4. The total fertility rate in Andhra is about 1.6 or 1.7. Karnataka it's 1.9. Maharashtra is again 1.9 or 2. It's only in the central belt of Madhya Pradesh, Bihar, it is approximately about 2.4 or so. Overall in India it is 2.14, which is just about the replacement population. So when we talk about India being a populous country, India being a consumer democracy, a consumer haven, India being, you know, the demographic dividend, well, big data shows it may not be true any longer. It may be that we'll have to plan more for geriatric medicine. I'm truly speaking. In fact, we may have to plan more for old age than for you know, the younger population boom. Because today if you look at the life expectancy, well, the average life expectancy is approximately 69. In some states like Kerala it is about 76 or 77, which means that somebody who retires, who's been a government officer, he retires at 60, he's going to live for 17 to 20 years after that, okay. So the government system is a sum of its parts, you know. Unfortunately in the government, and I keep telling this to every convincible government officer that I meet, they are the most brilliant guys. Obviously they get selected by the IAS and the IRS, and each one of them develops their own system. But the problem is the sum of the parts is never seen unless you have the big data. So we will talk about GSTN because this is what we implemented. Before I go further, three of my colleagues are sitting here. Can you please stand up? Sandeep, Gunjan and Ankita. They helped me to put this presentation together, and thank you. Yeah, all the tough questions you can give me. Thanks for giving the claps. So if you look at what had happened in the GST, you had annual GST invoices raised for supply of goods and services. You had, we have periodic GST and returns. We have 81.21 GSTR 3B returns that have been filed. If you look at the gross domestic data, Karnataka is 6886 crores, Maharashtra is 16,530 crores. The gross GST collected so far from our platform is approximately 1013184 crores. Okay. Now, what does big data do and how does big data help? Now, big data helps in last mile, which is missing, for tax evasion, tax avoidance, fixed registration, incomplete invoicing and fraudulent return of claims. And this is a sizable number. While yes, a lot of technology improvements can be done on the portal, a lot of it is also the resistance to change at the lowest level, where from what they call in North India a parchi economy, where if you go to a small shop he just gives you a handwritten bill, to a bill with a GST number, there is a lot of resistance. Now, what we do is, how do we cross verify transactions? First of all, we also have what they call the bill, the NIC-way bill, in the sense that you'll have to register the vehicle and the goods going. So there's a geo tagging out there as the vehicle moves. You also see how there is a cross verification of transactions, how there's a historical pattern determination, in the sense that all the while you have been paying 50 lakhs as tax, suddenly you say this month alone I'm paying 20 lakhs. Well, the computer catches you. Or you pay 70 lakhs and then go back to paying 50 lakhs. What was it in your life that you had to pay 20 lakhs extra 1 month? Okay. And aggregation, what we also do is, we look at triangulation. All of us have possibly a scientific or an engineering background. At least I come from a background which is civil engineering, so I know that if you don't take 3 points, you don't actually make a coordinate. So even in data sciences, it's that. So obviously you have to triangulate your GST with income tax with something else to make sure that this actually is what he says it is. Now, we talked about GST, we'll talk a little bit about income tax, we'll talk about India Post. We are also doing a number of projects for NDDB and the agricultural front, where we helped the government to increase the yield of the cow. So what happened was that sometime back NDDB came to us with, I wouldn't call it cow tagging, geo tagging, I call it cow tagging, cow and bull tagging. So they wanted to, we had the lowest production of milk at that point in time, 8 liters per cow per day, which is possibly the lowest among the world. America is at about 20 liters per cow per day. So they said, let us tag all the cows and bulls and see which is the pattern that sort of emerges as the best combination. Then then what they did was, they said, okay, we are going to do a bit of intervention, physical intervention, and they did insemination using a geotagging thing, saying that this is the way it will work, and using a lot of biology in the mix. And so today the produce of milk in the country is approximately 12 liters per cow per day. Okay, so obviously it has its uses elsewhere. In state, we have sort of looked at, we talked about Gujarat HRMS, we are doing something for the Maharashtra police, etc. MCA we talked about, but we'll look at some of these. Now, GST, going into a little bit of detail, there are 13 different types of taxpayers and caters to the commercial tax hierarchy across all the states in India. So it is the largest open source portal in the world. Every month 1 crore people are expected to come to it. It's about 60 or 70,000 now. Tax collected so far is $101 billion. I'm talking about dollars. And number of registered taxpayers is 11.4 million. There are 9 tax accounting head involved in every transaction. So if you look at the complexity, you can see the huge complexity over here that one has to go through for the data to be done. All this has been done using open source. There is no COTS product, not even a database. We haven't used Oracle databases, we haven't used IBM databases. I'm the most hated guy in the OEM community, but there is no OEM product. Okay, it's all being done by open source, Indian engineers. It is Indian. Okay. The technical complexity, so if you look at the data security, the entire business data is in one location, so we had to encrypt the sensitive data, we had to do row level and checksum for data integrity, we had to verify digital signatures. We have 25,000 concurrent users coming every day on the almost I have to plan for 25,000 users at this point in time. 50,000 invoice uploads per second and 3.5 TB data per day. It's a high concurrency data volume. The response time of 2 seconds or for 30 to 100 pages. Even that people shout is not enough. We are expanding it. Peak CPU usage has not to exceed 70%, so you can look at the amount it has to do. And it has been designed for 2x load on the portal, 5x load on the API, and scalable commodity. And what we have found, and this is my observation, having built such huge systems, x86 Intel hardware is more than sufficient. Okay. So I tell people I'm not going to send a rocket to the moon. I don't need your high-end servers. For what I do, x86 is more than sufficient, guys. Okay. So it's commodity hardware. And 0 RPO, 30-minute RTO, 99% availability, maximum downtime of 15 minutes in a month. This is the application architecture. If you look at it, you have at one layer, the portal layer, Nginx and Tomcat, you have Java Swing, you have Tableau, you have Spark SQL. The only one which possibly we pay for is the back office DB, which is MySQL. The others, it is Apache, it is Tom, it is Apache Gora, JBoss Data Grid, and JBRMS. It links up with MCA21, it links up with PAN, it links up with Aadhaar, it links up with the banks. And for MIS, you have R, Spark SQL, and Spark TB. So what do we do for what are the specific use cases? Network analysis. It analyzes payers through their business network chain. It identifies suspect pattern based on registration filing data. It creates risk profiling from all the filing data. It designs the business rule to perform risk profiling. There is revenue forecasting, which happens through time series machine learning techniques. It predicts who the defaulters can be, and there is segmentation and outlier analysis. So sometimes it is pretty scary even for us as to what can get thrown out. When I come to the end, I'll tell you what it is. In sheer numbers, we talked about 1.22 crore taxpayers, total returns 529.24 crores, payment transactions 9.38 crores, invoice uploaded 500 crores, payment through the portal 16.53 lakh crores, e-way bills 70.14 crores, highest return transactions a day 21.3, highest payment transactions a day at 9 lakhs. Outcome, as I told you, the biggest outcome is it is the largest open source ground up development project. I think apart from Amazon and Google, we are possibly the largest in the world. Okay, and it's an ecosystem with 45 plus Suvidha providers and 25 banks, about $151 billion collected, peak concurrency of 110,000 users which has been tested with less than 2-second response time, and peak traffic of 70 million pages. This is for indirect taxes. Direct taxes, we have been running it since 2012. We do high volume transaction processing. We are now building their next generation system. It is we have brought down using big data, machine learning, etc. We have brought down the processing time from almost about 6 months to 45 days. I'm sure many of you have been beneficiaries of this. Yeah, it's 20 days, I'm sorry. So these are some bragging rights over here. The biggest thing over here from a big data perspective is we can easily find out what exactly happens, how exactly everything relates to each other, and that's where big data machine learning plays a crucial role. This is the future, expected to go up to about 10 crore filings Per day we expect 1 crore filings, and this is big data as big as you can have it. Again, the entire architecture, if you see it, this is the functional application architecture. All of this is on open source. Of course, here they wanted Oracle databases, so we gave it to them. But most of it, excepting the Oracle DB, the rest is on Kafka, Java, etc. And we had IBM BPM tool, which we are sort of replacing with open source. So what are the AI and automation levers? One is the chatbot. I know it's a very small thing, but then a lot of it can be done using a chatbot. One is ticket triaging, health checks, alert management, job failures. Those are all internal things. But what we have done is essentially this, where you can, when we talk about a customer here, we are talking about demography, tax bracket, investments and subsidies. What is the correlation? What is the tenant landlord relationship? What is the anomaly in IT returns over different periods and time? Now all this would have taken you ages to find out, but this is done in a jiffy. Now, Ministry of Corporate Affairs. I'm going a little fast because just 1 minute. So if you look at the Ministry of Corporate Affairs, it is one, how many of you are aware of what the Ministry of Corporate Affairs does? Ministry of Corporate Affairs is the agency which registers a company. You have to keep the company alive. If you do fraud in a company, that's the place which catches you. It is the mecca for all companies. So it offers 130 e-services and forms. 18 lakh companies are incorporated. 150,000 filings handled in a single day. 92 lakh forms filed in a year, and 3.75 cumulative filings. We brought all this to a single form, and we said we brought down using big data, making sure that this guy is the right guy. We are less than a day for incorporating a company, which is equal to international standards. So today you can incorporate a company. You want it from now, we decide to form a company, tomorrow evening your company is done. Now Department of Post. The Department of Post is very interesting. It was a Rip Van Winkle organization. It dates back, the Postal Department dates back to 1858. The first deposit accepted by the Postal Bank was in 1888. It has 150,000 branches, which makes it possibly the oldest and large spread banking organization in the world. My parents had an account in the post office. I'm sure many of you, your parents and grandparents would have had an account in the post office, but they didn't computerize themselves. So obviously here you're talking about big data for one of the largest banks in the world with 60 crore accounts, where we process 2.8 million transactions per day, and we had handheld devices. We put our insurance solution there and the banking solution. The fun that I had here was I was able to see Mahatma Gandhi's signature, Mr. Nehru's signature. All of them were there. We had to digitize them, scan them, put it into the database. And we had 90,000 postmen equipped with handheld devices. So when you're talking about big data, you can't get bigger than this. 155,000 post offices throughout the country, 90,000 postmen with mobile devices, all of them linked to the post office, and all the accounts coming through there. What are the metrics? Obviously, business workflow optimized yielded 20x improvement for banking operations. That is why most of the DBT today can go through this. Processing time reduced by 33%, increased productivity, and centralized solution which prevents frauds. We did two projects there. One is the Rural System Integrator and FSI. Both are the same, but they're two different projects. Rural System Integrator was the handheld. We had biometric registrations where we said we said that people who are not the old lady who lives down the street in a village or in a hut in a village, what sort of a signature and all that. So we said, let's put this all into biometrics. So that's what we did, and we sort of did a lot of automation there. This is a project where Dr. Mukundra was involved. The problem statement around about 2007, 2008, and TCS was also a part of it. Nandan wrote out a report for, I think there was the UPA 1 government at that time for IT in the power sector. And one of the key aspects at that time was the aggregate technical and commercial losses were 33%. So how do you use information technology to reduce the losses in the power sector? So we implemented 17 modules: automated meter reading, GIS, consumer self-service, MIS reporting. We had physical consumer asset indexing. That was one hell of an exercise, wasn't it? And we had to go into each and every house. We had to go and map each and every pole. So that is your spatial analysis. The spatial analysis, what we talk here, is fine. Satellite imagery is fine. But when it comes to the last mile, where you have to map every pole and every house and every wire, it's an exercise with a lot of back-breaking physical work. And real-time flow of asset data from revenue to asset management system, update of service requests and field activities in real time, then SMS and email to consumers and utility staff, automated meter reading, and centralized customer care for every ESCOM. There are 5 of them in Karnataka. Infosys is still maintaining that system, will continue to do so till next year. The impact it created on the ground, there was a 2.5%. First, we never had, the DESCOMs never had a spatial map. They didn't have an asset mapping. So obviously they got that. And we reduced the AT&C losses from 28 to 17%, and we sort of had 80,000 automated meter readers who were able to take automatic meter reading. Okay. Now, I'll spend some time here because this is a sort of favorite of mine. The first generation systems, I would say we had transaction processing. The second generation, we had a whole lot of systems which gathered big data, which said there is going to be a lot of big data, etc. Some of these were spatial, some of these were not so spatial. I would say we are into the third generation of systems where we have machine learning and artificial intelligence built in. And today, some of the work that has been done here I've seen is quite fabulous. It's been a while since I've stepped out of the spatial systems, but then I saw some of it very fabulous. But then I think I was talking to Dr. Mukundra, I think there's a lot of headroom in the space for applying machine learning and artificial intelligence. The fourth generation, which is not very far, is quantum computing. And quantum computing, if it comes, I'm sure that what all we talked here today will be like a piece of yesterday's history. And yes, maybe there's a false start, maybe it's a true start, I don't know, because I obviously cannot go into Google to verify whether Sycamore was really good or not. But then there is a lot of quantum computing out there. In fact, when I teach at IIT Kharagpur, I take 1 hour on quantum computing, and we have to get prepared for quantum computing, which is a different world in itself, which will obviously help spatial recognition to be different. One of the key things is we talk a lot about data privacy. I think if you overlay spatial, if you overlay everything on top of each other, there will be nowhere to run, and there will be no place to hide. Yes, we can talk all you want about data privacy, etc. But I have been privileged to be involved with some of the police organizations. In fact, Infosys, we are helping the Karnataka police government to set up their cyber space. And we find that the benefits far outweigh the downsides. There will be a more just society. When my daughter is on the road, if I can track her using, now of course I track her using Google Locator, but if I can track her on my PC seeing that she is walking somewhere, if I can use heat images to know who is inside this room, imagine how much more peaceful would I be. If nobody can cheat on taxes, imagine how much more will come to the kitty, how much more can go to the poor. If the guy to whom it is meant actually gets the money and it's not swindled by some local goon out there, imagine how much more just it would be. So 3-4 things I would predict are going to happen. One is data accessibility. Physical intervention is going to be a thing of the past as people access data without even touching it. So it's not as though income tax guy is going to come and knock on your door or police guy is going to come and knock on your door. You'll get an SMS, please come to the police station. Okay. Data traceability and visibility. All data will be traceable and visible, and it will be unavoidable. You can't close it. Threat prevention and predictability. One is fraudulent activities. The second is, there's a nice article which I forwarded to somebody else. I can forward it to you guys also. AI had actually predicted the outbreak of coronavirus. Okay. Data privacy. At the same time, there are a lot of cyber security norms by which, for example, I was booting up my new laptop. It says, do you want to link? If I don't want to link, I don't want to link. But for me, I have nothing to hide, but so I link it. Thank you. So